What's up everyone, Patrick here, welcome back, and in this next video what we're going to talk about is the trapezoid mid-segment theorem. And not just in this video, over the next couple of videos we'll be dealing with this theorem. So in this particular video we're just going to go through an overview. There's not going to be really any calculations, and then after this video we'll do a bunch of examples, and it's all in order on the website. If you're watching this on YouTube, you can go to the description box and there's a link that takes you to the website. So what is the trapezoid mid-segment theorem? Well, if we draw a trapezoid, now remember a trapezoid has one pair of parallel sides. It's a quadrilateral that has one pair of parallel sides. So different trapezoids you can draw. Let's make something maybe like this. Right? So notice that this side and this side are parallel, right? And then this side and this side are not parallel. So again, these two sides here, they can take any sort of shape. You can maybe have a trapezoid that is like, maybe like that, for example, right? Where this and this are parallel, this and this are not parallel. It doesn't matter what kind of trapezoid you draw for this theorem. So I'm just going to stick with this one over here. Now, the mid-segment is going to be another line within this trapezoid where if we take the midpoint of this side of one of the non-parallel sides, so let's say right here, right, meaning that this length and this length are the same, and then we take the midpoint of the other non-parallel side, so let's say it's like over here, so that means this length and this length are the same. And then we join those two midpoints of those non-parallel sides. That's the mid-segment right there. Now, the mid-segment line, it's going to be also parallel to the two parallel lines. Sometimes these two parallel lines here, you'll see them called the bases of a trapezoid. But furthermore, not only is it going to be parallel, but it's also going to be, the length is also going to be the average of the length of the bases. Okay, so if we label these lengths, so let's say this length over here is x, this length over here is y, and then this length over here is z. This length, the y, it's going to be the average of the other two lengths. So if we take this length and add this length, if we add the lengths of the bases and divide it by 2, we would end up with that mid-segment length. And that's pretty much the theorem right there. You can also rearrange this, so you could put this over 1 and then cross multiply, and you could have 2 times the length of that mid-segment line equals the sum of the lengths of the bases. Right, that's another way that you might see this theorem shown. Both of these are the exact same thing. All right, and that's pretty much the theorem. And so what we're going to do in the next couple of videos is we're going to be given actual parameters, actual numbers to work with in a trapezoid, and we're going to be asked to find certain variables or certain parameters within these trapezoids, and we're going to have to use these this theorem to solve.